Hello everyone. In this video, we will talk about a very recent development in the telecom and ISP world, that is the TMF Open APIs, and how by adopting these open APIs as standards of internal as well as external operations, the CSPs or communication service providers can revolutionize the way and the pace at which they deliver services to their customers. We know that often to deliver an end-to-end service like an L3 VPN or a L2 VPN to a customer base spread throughout the globe, the CSPs often have to partner with each other depending on their presence in particular regions or geographies. So, a CSP can also assume the role of a customer to order such services from other CSPs. In such a scenario, it can bring great benefits if all the CSPs were to follow the same standards while defining their services and also making or acquiring systems that can work and interact as per these standards. While the TMF consortium provides a whole host of open APIs that help set standards and build all kinds of internal systems or processes that any large CSP can have within it, we are going to focus on the network services for this video. First, let me introduce the different components that are involved in the demo and how they interact with each other. First, we have the CSP's service ordering platform, which is basically a web portal that the CSP provides its customers with. This could be an enterprise customer or a partner CSP that might be ordering a service like a L3 VPN. They provide generic details like the last mile site address, type of service required, the network topology, etc. And also service specific details like bandwidth, IP subnet, network protocol level details, amongst many others. This service ordering platform in the backend will have the functionality of a TMF client and an event listener. Now, the service order received from the customer via the front-end portal can be converted into a service order.json file, which the TMF client then sends as payload to the TMF API gateway active on the Paragon Atom using its northbound REST API. This gateway has the capability of understanding and translating the service order, which is created keeping in mind the TMF Open API guidelines. The translated and extracted service level instructions and details are populated in the database as per the service YANG models, and underlying code then helps generate the service configs for the identified devices as per the regional point of presence, which can serve the local customer. Once the service is deployed on the respective network infra, Paragon Atom also sends out an event notification for the same, which can be used by the service ordering platform to inform the customer about the same. Now the customer can always come back to make modifications in the service, like adding a route, modifying the QoS requirements, or probably just changing the duplex of the customer facing interface. All these updates or patches to the service can be handled by the same pipeline where Atom's Open API gateway is capable to perceive these and send out specific config changes to the network infra. After all these changes, it notifies the event listener as well. Now let's jump into a quick demo to see all this in action. For the demo, we have imitated the functionality of both the TMF client and the event listener using two different Python scripts. I will be communicating with Atom using REST API CRUD operations to let it know about the different service actions it needs to perform and then update the event listener about major events. The event listener Python script is running in the parallel terminal on my PC with a destination port of 1111, and we will be able to see any updates coming in on that port from Paragon Atom. I will be authenticating on Atom to get a token to use for consecutive requests and then providing Atom the details of the event listener which run on my PC, and then go on to provide the service details as well. Before we proceed, we have some more details like the PE node, that is the selected device for service deployment, and the service ID for the L3 VPN service. Now as you can see, we have received the token, and now I will move into informing about the event listener on the Atom. To my right, you can see that Atom has received the task of creating the event listener. Now we will confirm with Atom once again about the event listener details. Now we'll move on to sending the service order to Atom, and as you can see on the Atom interface that the request to create a TMF based L3 VPN service has been received, and it is provisioning the same. So now if I refresh the services, in a moment you will be able to see that a new L3 VPN service request has been received. Once the service is configured by Atom, you can also see it listed in the services section here. We can also click on the command section of the task to find out the commands that was sent to the device. Here I have a CLI session with the same device, as you can see with the IP address, and we can see that certain details of this service have been configured. Another thing to notice here is that the event listener script has also got a new event notification saying that the service order attribute value change event. We can also confirm the state of the service order using its service ID or the state which it currently is in. Now we'll also try and update the service using a put operation. As you can see on the right, an update request for the service has been received and is under progress. Also, an event for the same has been received saying that service order attribute value change event. We can also verify from the CLI that one of the changes performed was the next hop of the static route which was part of the service. We'll do another update, this time using a patch operation. As you can see, another update request has been received and is under provisioning. And we have received another service order attribute value change event. From the CLI, we can verify that the duplex of the interface was the value that we changed using the patch operation. Now we will move on to deleting the service order completely and also deleting the event listeners config which was related to this particular service. Now, besides the service getting deleted from the Atom database, we can also verify the same from the CLI that all config has been deleted. Through this demo, we can understand how the implementation of these open APIs on Paragon Atom can really give more power to the customer by giving them a controlled access of the CSP's network infrastructure, and on the other hand, it can cut down service implementation times to a mere fraction for the CSP. Thank you and have a nice day ahead.